Greetings. My name is Mohd Razali from University Technical Malaysia Melaka, and I'm also affiliated with University Putra Malaysia, together with all the authors of these abstracts and also involved in the project. Okay, the title for our project is the development of IoT-based exoskeleton for elbow rehabilitation monitoring device. Right. So we will briefly on this whatever appears on this poster. Some of the introduction, this project presents an elbow exoskeleton. So that means we are actually constructing an elbow exoskeleton that will be attached to our elbow, and it can detect the movement of the elbow either in flexion direction or in extension direction. And also it has also the servo motor which can help the elbow to move or lift up. Right. So we use some of the components like the Node MCU. We have the potentiometer in order to collect data, and we also have the servo motor. And this microprocessor is also connected to Wi-Fi. It is a Wi-Fi enabled, so it can be communicating or transmitting the data collected to the cloud. In terms of cloud, we use the IoT platform. We use the Icmst, one of the IoT platform that is currently available in the market. Okay. However, we can also use other types of IoT platform. Just for this project, we use Icmst. Okay. Together with Icmst, we can view the result in the web, and we can also view the result using the smartphone. Okay, so the objective is mainly to monitor remotely the elbow therapy status, okay, via web and also via smartphone. So we have the data, we collect the data, and we save the data in the cloud. So that means later on we can use the data for reference. Okay, these are some of the components. We have the non-MCU, we have potentiometer mentioned just now, servo motor, non-MCU based, and okay, this is power data. So we use the power data in order to power up this exoskeleton. Okay, so that means we have this structure, and the structure will be for a person arm. Okay, so it can be used to monitor an injured arm of our patient. So that means we can monitor the recovery status. So we can get the data whether the person can stretch out his arm full extension, and the person can also pull in his arm in terms of flexion, so like a normal person. So if the movement is not similar with any normal person, okay, we know that the recovery is not quite enough. So the procedures is first we need to, and then we upload the program. This one we use Arduino together with the non-MCU. Okay, and next we where the elbow escalator, now the switch, and then just as we turn on the switch, it will start to collect the data once the movement is being detected, and we can see the real-time movement in web using PC or using laptop, and also using as a smartphone. We have an application that we call it as a Team View. Similarly, we can view in smartphone, and the same appears in the web. We can also use to control the servo motor, and we can also observe the real-time change in the graph. Okay, result on discussion. Okay, this has been and it can collect the data. It can send the data to the. Okay, so the illustrations. Okay, this is looks like the graph. This is how we bend the skeleton of the elbow extension. Okay, this is the graph, and when we full extend, okay, we can see it is in one line. So any person with injured elbow cannot really stretch out the arm in straight line. Okay, so in conclusion, the elbow skeleton monitor device may help in clinical and healthcare for monitoring patients' elbow rehabilitation status. Okay, so it is recommended in future, so we can upgrade the device to cater for more degree of freedoms. The one that we develop is catering for only 1 degree of freedom. And also in addition, we can use servo motor in order for us to use this device on a person with heavy arm. Okay, so that's all for me. Thank you very much.